it's Mrs. Nandor, and in this video we are going to look at how we graph density and how we can use density information to determine if something will sink or float. So let's talk about graphing first. So we won't always get just a set of density data. Sometimes we'll see a graph of density, and so we collected something similar in lab. And so when we graph density, we always do mass on the y-axis and volume on the x-axis. And so we get a line to represent our density. Now, what about that line represents density? Well, we know that density is mass over volume. What else about this line is mass over volume? Well, if we look at our axes, our mass is on our y-axis. Our volume is on our x-axis. Well, y over x in math class is slope. So the slope of a line from the graph for a density graph is the density of the substance. So the slope equals the density. So we can calculate that by hand. This means we can draw a line to represent a specific density. We could have a computer program calculate the density for us by finding the slope of the line that it creates. There are lots of different ways that we can get the slope to determine the density. Now, let's look at if we had two substances on here. So let's say there's another substance we measured and its density information went like that. Okay, so which slope is greater, purple or blue? Well, the slope of the purple line is much steeper, so it's much greater than the slope of the blue line. That means the density of the purple is much greater than the density of the blue. So we can just look at this. Even if we didn't care about the actual value for the densities of either of these, we could look at this graph and say, oh, the purple substance is much more dense than the blue substance. And we know that visually just because we can look at the slopes of the lines. Purple line has a greater slope than the blue line, therefore it has a greater density. Let's talk about how we can use density to determine if something will sink or float. So in order for something to sink, it has to have a greater density. So usually when we think about things sinking and floating, we're thinking about them in some sort of liquid. Often it's water, not always, but often. So if we want something to sink in water, it must have a density that's greater than water. So if something has a greater density, it's going to sink. The opposite is true for floating. In order for a substance to float, it must have a density less than the liquid it's trying to float in. So for instance, if we wanted something to float in water, it must have a density less than the density of water. Now, we won't always use water as our liquid, but we use it often enough that it's useful to know the density of water. Density of water is 1 gram per milliliter. So if we want something to sink in water, it must have a density greater than 1 gram per milliliter. If we want something to float in water, it must have a density less than 1 gram per milliliter. Like I said, water won't always be the liquid, but it is often enough and it's useful to know the density of water. So if you're trying to decide if something's going to sink or float, you need to compare the two densities. Whichever density is less is going to be on the top. Whatever density is greater is going to be on the bottom. Hi, it's Mrs. Nandor, and in this video we're going to talk about how we draw particle diagrams and how we analyze particle diagrams for density. So let's start with our first example. So we have box A and we have box B, and the particles in A and B look to be the same size. So the individual particles have the same mass. So let's compare the mass. So the mass we defined as the amount of stuff. Well, the particles are the same size, so the particles themselves have the same mass. So we determine which one has a greater mass by counting the number of particles. So A has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 particles, while B only has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 particles. So if the particles are the same size, which one has the greater mass? Well, A has the greater mass because it has more particles. So let's compare the volume of these two. So volume is the amount of space it occupies, so we're looking at the size of the boxes. What do we know about the size of the boxes? Well, without getting a ruler out to actually measure the dimensions, those boxes look to be about the same size. So we're going to say they have equal volume. So now we're going to look at how we can compare the densities for these two objects. So they have the same volume, but A has a greater mass in that volume. Since A has a greater mass in the same amount of volume as B, that means A has the greater density. We can also look at this visually with a particle diagram as representing the compactness of the object. So the particles in A are much more compacted than the particles in object B, so object A is much more dense. So the more compact the particles are, the denser the object is. Let's look at another example. So we have object C and object D. Both have 4 particles, but in this case the particles are different sizes. And the note here says larger particles have greater mass. So if they have the same number of particles, which box has greater mass? Well, the box that has the bigger particles. They have the same number, so now we're looking at the size of the particles. Object C has the bigger particles, therefore object C has the greater mass. Again, if we're looking at volume, we're looking at the size of the object, so they look to be about the same size without getting a ruler out, and we're not going to. They look to be about the same size, so we're going to say that they have equal volume. So likewise, when we're looking at the density, we're still looking at the compactness, but in this case, the bigger particles take up more space. So even though there aren't more particles, there's an equal number, we have one object that just has bigger particles. The bigger particles take up more space, making C more compacted, which means C has the greater density. And that also makes sense based on these two comparisons. They have the same volume, but C has the greater mass, which should mean in the same volume, whichever has the bigger mass is going to have the bigger density. So that means C has the greater density. When we go the other way, when we go to draw particle diagrams, if you want to show differences in densities, there are lots of things you can vary. You can vary the size of the boxes, you can vary the size of the particles, you can vary the number of particles. So changing the number of particles or the size of the particles is going to change the mass. So if you have 2 boxes of equal size, but you need to show one having more mass, you can either have the same number of particles, but make them different sizes, so that one object has more mass because they have bigger particles. Or you can make the particles the same size, but one box is going to have more particles to indicate that it has more mass. You could also do this by changing the volume. If you keep the mass the same, but make one box bigger or smaller, you can use that to show how density is different between the two objects. The main thing to keep in mind is that density is a ratio between mass and volume. So it's not something that you can only change by changing one thing. You can change the mass, you can change the volume to, when you're drawing particle diagrams, you can change how you represent those things to change how you represent different densities.